we will be having a quiz over the differentiation formulas tomorrow. The quiz follows what we see here. It is what it is, okay? So first off, for power functions, what I mean is if we have a function that is an x to the n. So what is the rule? Well, the derivative of that is n x to the n minus 1. Now, if we think about what that does, is you drop down the original power and the power goes down by 1. So you drop down the original power, the power goes down by 1, okay? So the power rule is really nice for a power function. Just drop down the original power, power goes down by 1, you got it. Let's talk about the product rule. I'm going to call it G. Here's why. It doesn't really matter, but I'm going to call this first and second. So you have two things multiplied together. Let's think of x and a sign. We can't really multiply those. So we're forced to use the product rule, okay? So the derivative is the first times the derivative of the second plus the second times the derivative of the first. So it's first times the derivative of the second plus the second times the derivative of the first. My writing is so beautiful. Okay, so the product rule again is first times the derivative of the second plus second times the derivative of the first. So hopefully that is of no surprise to you. I'm giving it to you. It's there where everybody's still writing. Very good. Yes. Mm-hmm. Now, our quotient rule would be if we have some function that has a distinct top and bottom that we can't really multiply, or I'm sorry, we can't really divide effectively. So they're kind of like, think about even a rational function like x plus 1 over x plus 2. You can't reduce that. You can't do anything about that. So you have to do this rule. So the rule is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, I'm going to write that down over here on the side. The bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. So if you have to say that to yourself 25 times, you want to always follow bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. And, you know, even tomorrow I'll give you this function. I'll call it top over bottom, just so then you have that as a little memorization tool. So I'll give you these three. And you would get a bonus if you give me both the actual function stuff and the words. Okay, so if you write out the words, I'll give you some bonus. Okay. Now, when it comes to the next ones, it is just a rule. You just got to memorize it. So for this one, if our function is a sine, our derivative is a cosine. So it's just a rule you got to memorize. So on the page, I'll have f of x equals sine of x. You'll have to tell me that f prime of x is cosine. So just a rule to memorize. So hopefully that's something that we've talked about a few times, that has to get, you have to memorize it, okay? Hence why we're having a quiz. F of x equals the cosine. Remember, the co's always get a negative in front. Just always remember, every time, if it's a co-function, it gets a negative. So the derivative of this is negative sine of x. All the co-functions get a negative. All the co-functions get a negative. Now, tangent and cotangent kind of go together. So if you remember the tangent one, the cotangent one is kind of a freebie. Here's what I mean. The tangent derivative is a secant squared. Now, the cotangent is a cofunction. So we're just going to tack on a negative and tack on the co. So it's kind of interesting that a cotangent derivative, I just tack on a negative. Instead of secant, it's cosecant. So it is negative cosecant squared. Okay, so let's look at the difference. The tangent is secant squared. Its cofunction, cotangent, is negative cosecant squared. So hopefully that helps you kind of link those two together. So if you memorize the tangent, the cotangent is kind of a little freebie. Now the same thing kind of happens with secant and cosecant. They go together, so they have their own little rule. Let's start with the secant function. It's going to lead us to the other one. The derivative of a secant is secant tangent. You got to put x with both of them because they are two individual functions put together. But the cosecant does just tack on a negative and put on the words co, and you got it. Okay. So our cosecant derivative, if I tack on a negative and then call each one of these, the above it, a cofunction. So secant becomes a cosecant, tangent becomes a cotangent. So it's cosecant, cotangent. So these two go together, tangent and cotangent go together. Secant and cosecant go together, the cofunctions. Sine and cosine go together, not quite that clearly. Sine becomes cosine, cosine becomes a negative sine. But you have to know your trig functions. It's going to go in that exact order. It's going to go in the exact same way. I'm going to ask you the same things. What's the derivative? And it's just memorize it. So you have tonight to get these stuck in your brain, hopefully. Okay. So write these out 10 more times. You can pull up a blank copy from Google Classroom as many times as you want. Every time you write it, it's sunk into your brain a little bit more. These rules are going to be here for the rest of this year. And then if you ever take a Calc 2 course, Calc 3, differential equations, any of those things, these rules are always used. They're like rules of algebra. They're just a rule you have to know. Okay. Any questions about those rules you have to memorize? Now, you are going to have 6 problems that you have to use those rules. Okay. They're going to look similar to what we see here. I'm verifying that for sure. Yeah, they look very similar. There's a few bonuses I've asked you about, some more intricate like tangent lines and things, but they're going to look like the 6 problems we see here. Okay. So let's go down the list and let's find each derivative and let's talk about the rules we have to use. Okay. So for problem number 1, that is a very simple derivative. We can just use our rules for polynomials, each individual piece. The derivative of that is 2. Now let's talk about why. Let's go down the rules. Because it's a polynomial, you get to do each individual piece. The derivative of that would be 2 times 1 times x to the 0, technically. But every time x, the derivative of an x is just the coefficient in front. The derivative of this is 0. That's why it happens. So this is really, if I didn't simplify on the first step, I'd get 2x to the 0 minus 0. And that's why it becomes what it becomes, okay? Now, since 2 is a fraction that cannot be reduced, we are forced to do the quotient rule. Now, I do not need any simplification, even one step of simplification. I just need you to do the rule, okay? So let's say our quotient rule one more time. Ready? The quotient rule is bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, okay? So that is what we have to use for a fraction. So let's use that rule for number 2. I just need you to set it up, first step only. I don't need you to do anything past that first step, okay? So bottom, put it in parentheses. So always start with bottom, it'll get you on the right start, okay? Times the derivative of the top. In parentheses, leave it. I don't need any simplification there. Minus the top, in parentheses. Times the derivative of the bottom. The derivative of x squared plus 5 is just 2x. Because the only one that has a derivative that isn't 0 is that x squared. The 2 drops down in front, it becomes x to the first 2x, okay? All over the bottom squared, write the bottom in parentheses squared. You're done. I don't care. Stop. You're good. Great. Okay. So that's all I need for the fraction one. So you're going to get a polynomial. You're going to get a fraction. Everybody good with 1 and 2. Okay. I'm going to give you a slightly more difficult polynomial for number 3. A little more difficult, but it's same thing. Okay. So the derivative, let's just use our power rule for each term. So this first one, there's a 3 sitting there. Don't care. It just multiplies by 3. Drop your 4 down in front. 4 times the 3 is 12. The x becomes a cube. Do it again. The negative 5 there multiplies by the 3. We drop down in front. Make that a 15. So negative 15x squared. And you can put plus 0 here. I'm okay with, if you like the fact that the 7 becomes a 0, go for it. Again, I don't need simplification really. So even if you put 3 times 4x cubed and then negative 5 times 3x squared plus 0, sure, yeah, I mean, it's right. So I'm okay with that. Everyone good with 3? Wouldn't it be great if they're all like that? They're not. Anyway, let's look at 4. Now, 4 we actually can make look like 3. It just takes one step before we do the actual thing. So my suggestion here is let's make our function x to the negative 2 plus 5x minus 1/2 x squared. So I would do a little rewrite for fractions that are rewritable. Now remember, in question number 2, our fraction wasn't a rewritable fraction. But in question 4, this 1 over x squared is rewritable as x to the negative 2. This x squared over 2 is rewritable because you can just put that coefficient as a negative 1/2 in front. So then you're not trying to do some kind of quotient rule for that because it's not necessary. Okay, does everybody see the rewrite and how it's useful for us now to do the derivative? Okay, so now we can do exactly what we did for number 3. We're going to drop the power down in front, power goes down by 1. Drop the power down in front, power goes down by 1. So it just actually becomes a pretty easy derivative. If you do the rewrite. If you don't do the rewrite, it becomes, gross. Okay, so let's go. Drop the power down in front, power goes down by 1. Drop the power down in front, it becomes a 1. Our x does become a 0. So if you know that that's a 5, that's really what I want. The derivative of 5x is 5. The derivative of 7x is 7. The derivative of 8x is 8. If you know that, that's what I want. If you write this, it's totally correct. I'm okay. I'm going to give you, if you interpret it one way, but it's correct, and I might do it, so I don't care. It's right, okay? And then the last one here, negative 1/2 would multiply by a 2 that drops down in front. So half of 2 is 1. So you just get a negative 1 sitting there, and then it becomes an x to the first. Yes? Okay, let's go over this piece again. Okay, so remember, whatever this power is, it drops down in front. Do you see how this became this? Okay, so this power, drop it down in front. So the negative 2 will drop down in front. When you take 1 off of something that is already negative, remember, it goes negative more. That's the way my brain kind of thinks about it. Negative 2 minus 1 is more negative, so it goes to negative 3. And that this power is something that my students in the past, they make mistakes like that. They'll want to call that a negative 1 or something. Remember, if my power goes down by 1, it's going more toward the negative. So if that helps. Does that make sense? Okay, any other questions about number 1 through 4, any of those? Okay, 2 more types you're going to get. In number 5, it is a multiplication of 2 things that I cannot multiply. So either put a dot between the things or put the things in parentheses so that you can contemplate that that's a first thing, 2x, and a second thing, cosine of x. Attach the 2 on the x, and then it just becomes, pretty simple. Okay, so the derivative, just like this one, use the quotient rule. This one, we have to use the product rule. So we're going to do the product rule. So if you want to say it with me, if it helps your brain do it. So it is the first times the derivative of the second plus the second times the derivative of the first. Okay. So that's what we have to use. So let's make this the first and this the second. Now, it is the first times the derivative of the second. Put everything in parentheses or 2x, especially like that negative sign, so it looks like a multiplication. Put that in parentheses. Plus the second times the derivative of the first. So that's one way you can write what we did. Now, if you do more simplification than I did, so be it, great. But all of these, I don't care about simplification at this time. I care, can you do the process? Simplification will come when we start to do more applications in chapter 3. In chapter 2, can you do it? Okay. In chapter 2, can you do this process? And then 6, although it has a tangent in there, it's a pretty straightforward normal one. It's not a horrible one. For that, you just get to take the derivative of each individual term because they're separated by pluses or minuses. So all you have to know for the tangent is the rule from up above. That's a secant squared. The negative 5x squared, the negative 5 is sitting there. The 2 drops down in front of it. So that would be negative 10x to the first. Now, if you wrote negative 5 times 2x to the first, actually wrote all that out, I'm okay. Again, simplification process is subjective. So I don't care if you simplify more than I am, go for it. And then you can put a plus 0 here for the 3, but you don't have to. If you want to, if you did, it's not wrong. Everybody good with those? Okay. So now at the bottom of the page, I'm going to do them pretty quick. When you're ready, they'll be displayed up on the board. So I want you to practice with those ones down at the bottom. And then when you're all done, please turn this in and then study. You have a quiz tomorrow. You have some homeworks you could be working on. So use the rest of class wisely, please. Okay, like I said, I'm going to do these, yes. So do these problems. I'm going to show you the answers up on the board so you have them as a resource. But don't look up until you're ready to check your work, okay? You're welcome. When I do mine, I'm only going to do the first steps only. I'm not doing any simplification really.
Okay, right idea, wrong answer.